I just don't bump it.
I'm very
So you guys got those? Any questions?
1, 4, and 10, how did you know that those are discontinuous points?
There's a couple ways. On one, I just looked down here and saw that if I plugged in -2 for x, that it would be 1 divided by 0. Wouldn't work. So there'd be a vertical asymptote, not continuous there. Or you could graph it.
I graphed it and I got a graph like that.
I didn't get one.
Yeah, so right there. Where they
So
both
it'd be
go
in
up.
between?
Mhm.
Okay.
That's where it is. Same thing on 4 and 10. Like
But
on
those
4, you could graph it and look at it. There's no breaks or anything.
Yeah, it was
And
just straight.
no matter what you plug in, you're good. The domain is all real numbers.
Is that okay with
And 10, it's just at -1, because you can't, oh, actually, excuse me, x can't be less than -1.
Yeah, because it went up.
Anything 0 or, yeah, you can't do the log of a 0 or a negative, so that's what happens. It is. The thing I didn't talk about, which I still saw most of you had it right, was part 11D, where it asked if f was continuous at x equals -1. And that's where the function stops.
Why is B 11 yes?
B, that's the limit as x approaches -1 from the right, and it does exist, 0.
What about C?
Because it was open circle.
No, it's not, -1. It's close.
Oh, I was looking at the 0, because that's it.
What?
C.
Oh, 11C?
Yeah, I didn't get that one either.
Shouldn't the limit be 0?
No, it's saying, is the limit as x approaches -1 from the right equal to the value of the function at -1? So if you look at the graph,
Oh,
line's blue?
that makes sense.
yeah, that-
Line's blue.
So, okay. So, it's
so yeah, is the limit as we get close to -1 equal to the value of the function at that point? And the answer is yes, they're both 0.
Okay.
So if it was like the limit at the value of 1, it approaches 1. Is that
Equal to f of 1?
That has to be no.
That answer's no, and that's problem 12C.
Okay.
They ask you that. Right there in 12C, they asked, is the limit as x approaches 1 equal to f of 1? And it was no, because f of 1 is 1, the limit as x approaches 1 is 2, because there's that discontinuity there.
How come then? Okay, never mind.
Everything else pretty straightforward. This whole part of what kind of discontinuity it is, I didn't think that was really important. You should just know if they're removable. I'm going to show you how to today
Oh, I
where
have to
removable
understand.
discontinuity is, and how to remove it, how to redefine the function so that it is removed.
Wait, you want it removed? You don't want it removed?
Yeah,
You want it removed?
we'll see. Any other questions on this?
How do you know x? I mean 14?
14, it's just, what was the question? Where is it continuous? Well, it's just, you
All
just-
the points that are.
yeah. It's so from like -1 to 0, it's a solid line. It's continuous from there to there. But at 0, it's discontinuous. Then again, from 0 to 1, between those, it's continuous.
Okay.
From 1 to 2 and from 2 to 3, between those intervals.
Okay.
The one I thought you would ask about was, is f continuous at -1? This 11D. because it's an endpoint? I thought y'all would say no. You figured it out, and that is correct, because if I would have actually given you notes yesterday,
Would have been nice.
well, here you go. Let's actually write something down. Pretty good though for not having any.
Yeah.
And I thought you would. I was like, this is pretty straightforward. They don't really need notes. They can handle it. So let's see. 2.3. The actual formal definition. It's like I'm worried about my spelling now that I know that camera's on. It's like how you spell definition. Subconsciously thinking.
They just heard you say that.
I know. I have to edit that out later. I'm sure any casual viewer would be bored by this point and have turned it off.
Yeah.
So, only the people that would still be watching actually.
So the only picture showed was the homework.
Yeah. Anyone who just watched it that was just curious is like, man, this sucks. So now it's
Glad
just,
I'm not taking
it's just
account.
3 there.
You should put like a warning. This is for my calculus students. No one else watch.
This is very boring.
Does this mean you have to friend all of us?
I don't think so.
You have to friend one of
I'm
us so
just-
that someone can tag us.
Yeah. Figure it out later.
You could create
Is
a
it-
Are you
page.
gonna post it on Facebook?
Or somehow post it to where they can see it. YouTube, yeah, YouTube would be better. And I don't have
Then you're really gonna get hits.
to. Oh, yeah. 1 million views by the end of the week. So, continuity. This is the actual definition. What'd she say?
Just from Briley.
Oh,
Literally.
it's funny.
That was great. That was great.
Sorry, Brenda.
That's also.
Just gonna hear that.
A function is continuous at a point C if the limit as x approaches C of f of x equals f of C. I mean, that's kind of just duh. I don't know. Just means if we got a
As the
function
line approaches it.
as we approach a point on x, if the limit is the same as just f of c, then it's obviously continuous at that point. Like that one we just did, where, let's say you had just a curve like this, and I said, what is the limit at x equals 2? And you'd be like, oh, it's 4. And then I would say, what is f of 2? It's also 4. So that's obviously continuous at that point.
Oh,
But if we
okay.
had one that was like this, and that was 3, and that was 4, and that's 2. The limit as x approaches 2 is 4, but f of 2 is 3, so that's not continuous.
Wait, the limit of f of 2 is
On this one, it would be,
30. Oh, wait,
which one?
Let's go.
on the bottom.
It would be 4, because as we approach 2, we get close. This is just a little crappy drawing here.
Mhm.
As we approach 2, we get close to 4. But f of 2, at 2, the function is equal to 3, so it's not continuous. That was pretty straightforward. But then, so the part about the endpoints is next. And this is, so we're continuous, it's called continuous at a left endpoint A if the limit as x approaches A from the right to f of x equals f of A. And that's what happened in number 11. As we approached -1, the function, the limit was 0, and f of -1 was 0. Therefore, we call it continuous. Even though it stops and it's an endpoint, it's just called continuous at the endpoint. Same with on the right. Continuous at right endpoint B if the limit as x approaches B from the left of f of x equals f of B. did the homework, and I didn't even tell you that stuff, and well, you got the right answers. It's pretty
Of
intuitive.
course, you don't know about the feedback here, though.
It's true.
Watch this video.
Nikki, how do you do?
Good, that's good.
He didn't do it.
That's why he's not here.
He's afraid.
Now you can get all the answers and come to class on me.
Okay, let's do what I was talking about just a minute ago. Let's remove a discontinuity. Spell that. Yeah,
Bradley just texted me, she's like, take notes please, good ones. Like, you're gonna watch them.
right. Shouldn't be texting students in my class, please, brother.
I got one too.
Oh, so you guys are checking them.
Yup.
Let's let f of x equal
You submitted that on camera.
x.
See, I didn't have to check it. It just vibrated. And it was her vibrate. You set the vibrate so she remembers.
So let's look at this function. First thing I want to talk about. You done with that stuff up there?
Discontinuity,
Okay, this continuity.
stupid word.
Let's, what's the domain of this?
All the numbers except for
Well, yeah.
Yeah, x can't be 3, right? Anything else?
Negative 2, because if you square it,
Maybe.
Yeah,
it'll be
'cause
positive.
it can't be negative 3 either,
So,
right?
Yeah.
that's the next one.
Okay. Let's take a look at the graph. What this looks like. And see what's going on around 3. See what kind of discontinuity it is in that sheet I gave you
Let's
yesterday.
see.
So x to the third.
Let's see again.
I'm just getting it. I'm watching.
I know you're probably just watching on there instead of the
You're just
board.
watching on the little screen.
I'm making sure it sees everything.
Graph that. Oh, look at it.
Like a sonic sound.
It's infinite.
What happens at 3?
It keeps going.
Does it show any discontinuity there?
Maybe if we do.
Let's zoom in. Yeah, good idea. Let's just go zoom in. I'll go to. I could have just changed my window. Probably would have been smarter. Let's see what happens.
How did you just do that?
I just hit zoom in. I went to it. But I'm not going to do that anymore when I change my window. So I want it to be right around where x is 3, so I'll go from like 2.5 to 3.5. Go by 0.5s. And, oh, what was y equal to? I don't remember. And we'll see if I'm close. Uh-oh.
All these little bugs.
You see it?
Yeah.
There's a little tiny dot missing. So let's get closer.
Oh.
Stupid.
What?
Wait,
That
how do
is so
how do you tell it
dumb.
where to zoom into?
Right there. About 3, and y is about 3.3. So I'm just changing my window. You could tell it to zoom. Let's go like 2.8 to 3.2. Down here we'll go like, what did I say, 3.3? So 3.2 to 3.4. Oh, yep, see the break? And then we can zoom in even further. I mean, we can get crazy with this. There he is.
He's just zooming in now.
What kind of discontinuity is that?
It's stupid.
Remember from your note sheet?
Removable.
It is a removable. At x equals -3. Remember what that looked like? I don't want to zoom back out, but was that one
It was
removable?
infinite or something.
there was an asymptote there,
Yeah.
wasn't there? So that one's not removable. So we're not even gonna worry about that one. But this one is removable, so we're gonna go ahead and remove it.
How do you know it's removable?
Right.
Huh?
How do you know it's removable?
Because there's just a hole there. Like, remember the sheet I gave you? It's all the
Oh, yeah.
discontinuity. When there's just a hole, it's removable.
Okay.
That's what we're gonna do.
As in you could put a point somewhere else.
Not somewhere else necessarily. Here's what we're gonna do. Let's figure out about what, when x is 3, what the function should equal. What it should if there was no hole. So how do you figure that out?
We put
You
a
could do,
little
like-
dot thing in the hole.
You could,
Put a dot thing.
A little cross thingy. Yeah.
Oh, like that?
Yeah.
So about 3.33, is that what you're saying?
Mm-hmm.
Yeah. So you're saying that f of 3 should be about 3.33.
are you gonna do like the table thing?
Yeah, let's
You
check
have
the
super, super, super small, what does
Yeah,
it
let's
get close
check.
to?
Yeah, let's check the table. We want to be sure here. So let's see, I want my table to start at x equals 3. And we'll go like that.
So we're pretty much finding the limit.
Pretty much, yeah. Yeah. Yeah, that's exactly what we're doing essentially. I think 3.33 is a good answer. I mean, I bet if we went smaller, we're pretty much finding, we are finding the limit as x approaches 3. So yeah, you want to say 3 1/3? So,
Just put a line over it.
well, let's just go 10/3. That's 3 1/3, right? That's the actual. So it should be about 3.33. Well, let's check this out. Can you factor the bottom?
Yes.
Yes.
Yeah, it's easy, right? X plus 3, x minus 3. Agreed? That's easy here. Can you factor the top?
Not that I know of, because there's a third.
What's the?
Were you gonna try? Grouping? There's no x squared term. Good idea though. Anything else? No, we've never really factored any that are just x to the third, but okay. Do you think that maybe one of these factors is the same as up here?
It's possible.
Because like, why wouldn't there be an asymptote at 3? If I have x minus 3 on the bottom, shouldn't there be an asymptote?
Cancel.
Yeah, what if they cancel? Is there a way we could check if x minus 3 is a factor of that?
Divide.
Yeah. Now you're speaking about pre-calc.
Be synthetic though.
How can we divide?
Do either synthetic
What's
or
synthetic division? Yeah. I can do. What do you like?
Do this.
Briley's at home right now. She's doing long division.
Yes. I want synthetic, so go ahead and do
Synthetic.
synthetic.
I like either way. I don't care. So 3. Let's see. What would it be? 1, 0, -7, and -6. Remember that? You got to put the x squared in there.
Mhm.
So let's see, we go 1, 3, 9, -2, and -6. No, it's not
You
-2.
want 3.
I was like, wait,
No.
something wrong. Yeah, it's +2.
Yeah.
Duh. 6, 0. That's embarrassing. So hey, look at that.
Works out perfect.
Yeah, that'd be x squared plus 3x plus 2, right? So really, the top factors, x minus 3 times x squared plus 3x plus 2 over x plus 3 times x minus 3. Is that factorable?
Yeah,
It is, isn't it?
x plus 1, x plus 2.
X plus 2 times x plus 1. Okay, that didn't really do anything though.
Yeah.
Because the only thing that cancels is there and there. So really, I can just go back, it doesn't matter. X squared plus 3x plus 2 over x plus 3. That's like a reduced form. Now, though, so would you say these two are equal, essentially, since we cancel that out? Let's find the limit, just to confirm this. Let's find the limit as x approaches 3 of this function right here.
Of the top one?
Oh, right here, our reduced one. Our x squared plus 3x plus 2 over x plus 3.
Because it'll work now since it's
Yeah, it'll work
zero.
now. We'll get an exact answer.
20 over 6, which is 10 over 3.
Ooh.
It's not that hard to figure out.
Congratulations, please give me a piece of your brain. I really like it.
That's the easy part. I'm just saying you should know this. That number should sound familiar.
Yes.
So, because we have 9 plus 9 plus 2 over 3 plus 3. 20 over 6, which is 10 over 3. So we were right. So what's it all mean? That is the point we need to insert there to remove the discontinuity. That's all we've done, is confirm that. So the way we do it,
And, never mind, go on.
go.
I was gonna just ask how, how do we get that top? We just, that
We
was
just
what-
zoomed in
yeah.
and guessed. And guessed right.
We were lucky guess. Okay.
It probably won't work all the time.
I knew what the answer would be, so that kind of helped.
But still, like.
But still, you guys saw it, you know, it wasn't just like I was making it up. So, what we have now, we call this our
Our answer?
our continuous extension of f of x. We'll call it g of x. So g of x is just going to be taking f of x and making it continuous. Or as continuous as we can make it.
Continuous extension. I feel like I'm English. Go on.
G of x will equal, and this will be a piecewise function.
Yeah.
It'll equal x to the third minus 7x minus 6 over x squared minus 9. That was our original. As long as x doesn't equal 3. We can't remove that one, right? That one's got to stay. But it will equal 10 thirds when x equals 3.
Jibba jibba jibba.
On the top one, do you have to do plus or minus 3?
Yeah, you should. I think.
So you have to go back to your original equation.
Yeah. That's my test below. So we've included x equals 3 now. We can't include x equals -3. That's it. That's all you gotta do. It's not really that hard, is it? It's kind of a long process, but
Very long
I
process.
just did it twice.
So what did Dave, oh shoot. You have to include negative,
She was saying right here, include -3.
so can you just put plus or minus?
That's only for that one point that you can actually change.
Yeah.
The other point, because it's an asymptote, you can't change it.
Such a way with words.
You take my heart.
And also, in this next piece, you're gonna see something else.
Because
You cancel stuff out.
So you factor out the x minus 3, or x minus 3.
No, 4 minutes. Let's
That's what we were discussing.
go. And I think another reason why they don't have -3 listed is because of this. Continuous functions. continuous function is a function that is continuous on every point in its domain. So if the point is not in its domain, that's fine. Like -3 was not in the domain of that problem. But we still call the function continuous at that point. Weird, huh? I just see a bunch of confusion. We have continuous functions and, what do they call it? Continuous on an interval. A continuous function is a function continuous. Continuous is a weird word and you write it like 6 times in a row.
Yeah, I wanted to say it
In
continues,
there.
not continuous, continues. The
Continuous.
function continues.
A function continues on every point in its domain.
In fact, I'm going to say that in my own words. The function continues.
Nippy is continuous.
Yeah, function is continuous.
No, a function that is continuous. A function continuous.
Yeah, we know you're a math
It's
grammar, not a
function,
grammar.
comma, continuous. That makes sense.
The function
Makes sense.
continues.
It does. It's a
On every
function
point
continuous.
It's a function,
on-
comma,
You need a
continuous
comma.
on every point.
This is math class.
Pause. A function, pause, continue.
On every point in.
Okay. Function that is
Thank you.
continuous on every.
Or a function continues on every
No,
point.
that doesn't make sense.
That is
Why?
These, there's also called continuous on an interval, so these don't have to be continuous on every interval. You know what I mean by interval, right? Like a set of x values. So like for our last one, it wasn't continuous on -3, but that's fine. Because there's an asymptote there, it's not in its domain. For example, the function f of x equals 1 over x. Would you consider that to be a continuous function?
Yes.
You might want to say no, because why? There's a big asymptote right in the middle, right?
But it still keeps going.
But the asymptote isn't in its domain.
That's
That's
right,
okay.
that's what the weird part is. Yeah, if I showed you that, whoops. I zoomed in. If I show you that graph, you're like, probably gonna say, no, that is not continuous. I mean, there's an asymptote there. But that's not in the domain, so this is considered a continuous function.
That's stupid.
Because there's no split, correct?
I'm so confused about the +3 and the -3. Like, why was +3 in the domain of -11?
It's not, but we removed
Don't
it.
just,
But we
don't let it bug you, Jay.
magically made it.
Move
We
on.
removed it,
Move on
yeah.
with life.
Okay.
Because it was removable, so
Why
we
couldn't we
removed
get
it.
-3? Because
it
it
wasn't
doesn't
part of the
factor
top.
out of it.
Because it, yeah, it doesn't, yeah, it's
Okay.
not part of the top.
Nope.
It didn't
Don't let it
factor.
bug you, just move on with life. I mean, I don't get this whole
Nicole's like,
class,
I-
but
I'll just accept it.
I don't get this whole
It
class.
wasn't a removable discontinuity,
So
it
if
was
it
an
was-
asymptote.
It was switched around so that we could cancel out x plus 3, then we could have added that.
Yeah.
Okay.
Like, we changed the function a little bit and included both of them, there'd be 2 holes, but we could remove both of them. And actually, most of the functions that you know about are continuous functions. For example, polynomial functions. I know sometimes these words mess you up, so what are polynomial functions?
I don't know, can you draw a little
The ones
picture?
with exponents.
Yeah, any x squared, x to the third, x to the fourth, blah, 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 blah. Those are all continuous. Because, well, their domains are all real numbers, so that makes sense. There's some that don't.
Always, no matter what.
Absolute values functions.
Yep.
Big V's, those are continuous. Actually, all of these are going to be continuous. I don't know why it's not. Yeah, continuous.
Close enough.
Yep. We've really lost lost a lot of viewers by this point. So it doesn't matter.
He'll probably get like Rust watching it or
I
something.
was just gonna say that, but I didn't want to be on camera saying that. No,
I don't even think he would last this long. It's really boring. So those, what else we got? Any rationals, which is what we just had. Remember rationals, like fraction. They're continuous functions, even though there may be asymptotes, because those points aren't in their domain. Anything, exponentials, logs, those are exponentials, inverse of them. Any of the trig functions, any of you, even your square root graphs, your radicals, even though they stop and then they just go one way, they're considered continuous because they're continuous on every point in their domain.
So what is in a continuous function?
You'll have to stay tuned.
Until?
That's what I was just thinking. I was like, to get people to actually watch it.
Yeah.
Like,
Tune in tomorrow and you will find out the answer.
if you keep watching, we'll give you a prize. Like, there's a prize at the end. You have to watch it all
Come
the way.
in tomorrow and tell me that you got this far, and I will give you a, what do I have? I have some candy. So if anyone out there watched this far,
Besides the people actually in the
Oh, yeah, what's
class.
actually in the class?
doesn't include people in the class.
Aw.
Here's your homework. 2.3, I need to go print, I need to go copy the book. Oh, we have to delete that, it's copyright. In your books. QR, I want you to actually do the quick review, so when I QR, that's the
I like
ones
that.
you always mess up and
Thank
try to do. QR 137, and then do the regular exercises. Numbers 19, 22, 24, 5, 6, 31. Seems like a lot.
Number 1, 3, 7.
26.
Yeah.
24. And for you guys listening at home, yes, the homework is still due tomorrow.
Yeah.
Yeah, it is. Good point.
If you're not here, you can add 3 extra problems.
Let's just go ahead and shut this off.
Show your face.
Say goodbye. It's all blurry because I just do it really fast.